Hello, welcome to section 3.2. Here are the answers for 3.1. Let me know if you guys have any questions. Today we're going to be working with 3.2, which is basically a lot of what we did in 3.1, except for there's going to be one new condition that's going to change a lot of things for us in a good way. It's going to allow a lot of new theorems to develop. What we're going to be working with is parallel lines and transversals. So yesterday we just had two lines. Now we're going to have two lines that are parallel, and a bunch of our special angle pairs are going to have relationships. So what I'm going to do is this is an investigation I used to do, but what I'm going to do is I'm going to take angle 2, which is my exterior angle, or my exterior, and I'm going to go around to number 7. I'm kind of show you guys what happens here. If I move that over, slide it down there, okay, to show you that those two angles are the same if the lines are parallel. Let's take a look at an alternate interior pair. So here's one of my interior angles, and if I rotate that around and go to the alternate side, so now number 6, those two angles are going to be the same. And how about a pair of corresponding angles? The corresponding angle of number 6 is number 2. If I slide that up to number 2, you can see that the corresponding angles are the same. And the last special pair was the same side interior, or the consecutive interior angles. And they, as you can see here, if I slide that around there, I don't even know, this is like impossible, because they're not the same. So yeah, you have 3 pairs of congruent. The fourth one is actually a little bit different. It's supplementary. Now, how do we show that? Okay, well, we know that, let's see, 2 and 4 are linear pair, and 2 and 6 are the same. So we know that 2 plus 4, those are a linear pair, so they have to 180. And 2 and 6 are the same, so if I replace the 2 with the 6, 6 plus 4 equals 180. So this is just a quick little overview on why those two angles, the same side interior angles, are supplementary. And we're gonna formalize all this stuff into proofs actually. So here we go. The first one's a postulant. We don't have to prove this one. We're actually going to use this one here to prove all the other statements. Okay, so it says if 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. This not only works for 2 and 6, it also works for every other pair, such as 1 and 5. 1 is congruent to 5. And it also works for every other pair. So we put 3 in here, and 7. Angle 3 is congruent to angle 7. 2 and 8. All of those are the same. Okay? The measure, here's a sample problem. The measure of 3 of the numbered angles is 120. Which ones are 120? Well, I'm going to start off with this one right here, angle 4. Angle 4 is one of the answers because those are vertical. This one here, 5, they're corresponding angles. They're the same. And then 5 and 8 are vertical. So angle 8 is also 120 degrees because they're vertical. So those would be the 4 angles that are all 120. So 120, 120, and 120. And you can actually figure out what all the other ones are. They're all going to be 60 because they're all linear pairs. 60, 60, 60. Okay, next up is 3 theorems. They're all basically the same theorems except for the last one is slightly different. Alright, let's go through each one at a time. Here we have alternate interior angles. If 2 parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So not only are 4 and 5 are congruent, but 3 and 6 are also congruent. And the next one is alternate exterior, so not only is 1 and 8 congruent, 2 is also congruent to 7. And the last pair, this is the one you got to be careful with. This is the other one that's kind of trickier to explain and show you guys. It's the consecutive interior angles. they are going to be supplementary. So they're going to have to add up to 180. 4 and 6 also supplementary. So there you go. Those are the three theorems. We're going to prove all three of those within either the video or within the homework. I'm going to do one of those for you guys. Prove that two parallel lines cut by a transversal and the pairs of alternate interior angles are congruent. So this is the interior angles one. Alright, so we're given P is parallel to Q. We're going to do a 2-column proof. These are the types of proofs that are in your homework, and you're going to be seeing these on your quizzes and your tests. So we're going to start with our given P is parallel to Q. Given. And I know angle 2 and 3 are vertical angles, so angle 2 is congruent to angle 3. Vertical. Now, because the lines are parallel, I can use the corresponding postulate. Okay, that was the corresponding angles was a postulate I get to use. That was a freebie. So I know that 1 and 3 are congruent. Okay, corresponding angles, and that one is a postulate. Corresponding angles postulate. And now, since 2 is equal to 3 and 3 is equal to 1, I can say that angle 2 is congruent to angle 1. The transitive property. So we have just shown that angle 2 is congruent to angle 1, which is what I was trying to prove. The measure of angle 3 equals 68. And the measure of angle 8 equals 2x plus 4. What is the value of x? Well, if 3 is 68, these lines are parallel right here. I have the arrows. Okay, so that means this is the corresponding angle. So that would be 68 as well. And 68 plus 2x plus 4, they form a linear pair. So they have to add up to 180 degrees. So what I'm going to do is I'm going to solve this equation for x. And you're going to be doing a lot of these types of problems in your homework where you figure out what x is based off of the angle values. Divide by 2 on both sides to get 54 for x. So those are very typical geometry, algebra-based geometry questions. And that's all I got for you guys today. These are quick questions. These here, those are proofs. Make sure you attempt them. And these are challenge questions. 35 and 36 are challenge. They're kind of fun, but they're difficult. Well, sort of. Give them a try. They're fun problems. Thanks, guys.